We are in the lecture series of Digital Electronics KE 039/049. I am Dr. Kishanu Kundu, Assistant Professor, Department of Electronics and Communication Engineering, GL Bajaj Institute of Technology and Management, Greater Noida. Okay. So, we are in the lecture number 17 and today onwards we will be discussing the counters. Already in the previous lectures we have discussed about flip flops, flip flop conversion. Now, from today's onwards we will be discussing about counters. So, this is the counters lecture part 1. So, first of all we will discuss what is counter. It is a digital circuit which is used for counting pulses. Okay. Count is wide application of flip flops. It is a group of flip flops with a clock signal applied. Counters of two types, means already we have discussed about flip flops. Flip flops, when we take a group of flip flops and it is used for some counting purposes, it is called as counter. Okay. There are two type of counters, one is asynchronous, it is having another name as ripple counters, and second one is synchronous counter. So, the main difference of asynchronous counter and synchronous counter is depending on the type of clock pulse applied to the flip flops. So, suppose we are having two flip flop A and flip flop B. Let it be any type of flip flop, SR, JK, D, T, any type of flip flop. So, suppose we know for every flip flop we have to give some clock pulse. So, now we have given clock to the first flip flop and it is having two outputs QA and QA bar. So, now if the output of first flip flop is taken as clock for the second flip flop, this is called as asynchronous clock counter. Okay, means what are doing? We are giving the output of first flip flop as clock input to the second flip flop, and like that. If we are having n number of flip flops, like that it will having. If this will be going to as a flip flop C, like that it will go on. Okay. This is QB will be given as a clock input to the next flip flop, like that. But if we having 3 flip flop 1, 2 and 3 and simultaneously we are giving the clock pulse in each flip flop, then this is called as synchronous, means same clock pulse is given at the same time to each of the flip flop, then this is known as synchronous counters. Okay. So, depending upon how clock is applied to the flip flops, the counters are two types, asynchronous and synchronous. Okay. So, this is the difference of asynchronous counter and synchronous counter. Already we have discussed output of first flip flop drives clock of next flip flop, whereas in synchronous counter all flip flop are triggered with the same clock simultaneously. Okay. Next, asynchronous counter is also called serial counter and synchronous counter is also called as parallel counter. Say synchronous counter will operate only in fixed count sequence, up or down. Okay. But synchronous counter having an advantage will operate in any design count sequence. Next, asynchronous counter examples are ripple up counter, ripple down counter, etc. Synchronous counter examples are ring counter and Johnson counter. Next, asynchronous counter is slower than synchronous counter in operation. Yes, because the clock signal of second flip flop will be depending on first flip flop, right. But in synchronous clock signal is at a time, same clock signal is given to all the flip flops. So, it is more faster, synchronous counter is more faster. Next, classification of counters. Classification of counter, depending on the way in which the counter progresses, the synchronous or asynchronous counter are classified as up counter, down counter and up oblique down counter. Like that, suppose I am a equation 0 0 0 1 1 0 and 1 1. So, it is counting from 0 to 3, it is counting from 0 to 3. So, if we are counting like this, first 0 0, then 0 1, then 1 0, then 1 1. So, this thing is called up counter, this is up counter. Now, if it is in reverse order, means from 1 1, then 1 0, then 0 1 and then 0 0. So, this is down counter, and one circuit having doing both the counting up and down. So, that is called up down counter. So, here for up down counter we will be having one extra mode control M. So, when mode is 0, mode control is 0, then up counting will be done, and when M is equal to 1, then down counting will be done. Okay. So, these are the classification of counters, and similarly synchronous counters also can be classified as up and down counter, as well as asynchronous counter also can be given as up down or up down counters. So, now we will start with designing of the synchronous counter. Okay. Synchronous counter means same clock pulse is given to the each of the flip flops at the same time. Okay. So, here we are having one question, design of a 2-bit synchronous up counter. Here every point is very useful. See, synchronous means all flip flops will be given clock pulse at the same time, and up counting means it will be coming from 00 to 01, 10, 10, 11 like that, up counting. And one more thing is 2-bit, 2-bit is very important, means 00, 01, 10 and 11. When there are 2 bits, then 4 combination 00, 01, 10 and 11. Okay. So, these 3 things you have to check first of all from the given question, okay, what they are wanting. Okay. So, now we will be going for the steps. First of all, we have to decide the number of flip flops, because we have already told that counters are nothing but a group of flip flops. Okay. So, how many flip flops we need, that is given in the question itself, 2-bit. So, 2 flip flops are needed. It is called 3-bit counter, then 3 flip flops. Number of bits is equal to the number of flip flops. Number of bits is equal to the number of flip flops. So, here we need 2 flip flops. So, here another question, which flip flop we will take, SR, JK, D, T, it is up to you. Any type of flip flop you can check. Okay. Now, next is draw the excitation table of the flip flop. Suppose we have taken SR flip flop, 2 SR flip flop. Then now we will draw the excitation table of SR flip flop, right. Then we will draw the state diagram of the circuit excitation table, then simplified expression using K maps, and final the logic diagram. So, check one by one we will do that. So, first of all 2-bit 2 flip flop means up counter, next is up counting, next is called up counting. So, up counting means 2-bit means 00, 01, 10 and 11, 4 combination. Now, state diagram up counting. So, 00, 01, 10 and 11. So, up counting means like this, it will be counting like this. Is it clear to all of you? This is nothing but the state diagram. Okay. So, here 2-bit, so n is equal to 2. So, number of states will be 2 to the power n, means 2 to the power 2 means 4 states, already 4 states, and maximum count will be 2 to the power n minus 1. So, it will be 4 minus 1 3. So, it will actually doing what, counting 0 to 3 only, na, 0 0 0 1 0 1 0 means it is 0 1 2 and 3 in decimal. So, it is counting up to 3 maximum count, clear. So, now the step is given as draw the excitation table of the flip flop. So, here we are taking JK flip flop, I have given, you can take any one, I have written SR flip flop, let us take this is as JK flip flop. So, this is JK flip flop we are taking, right. So, we have to draw the excitation table of JK flip flop. So, already this excitation table is covered in the lecture video of JK flip flop, you can refer that. So, we will be writing that excitation table 0 0 0 1 1 0 1 1. So, we will be having 0 cross 1 cross 1 and cross 0, cross 1 and cross 0. Okay. This is nothing but the excitation table table of JK flip flop, excitation table of JK flip flop. Okay, clear? So, already I have told you that 2 flip flops are needed, and then we have to write the excitation table of JK flip flop, then state diagram. So, already this is the state diagram, states are there, already we have done this. So, now from state diagram we have to write the circuit excitation table, this is very very important. Using this state diagram we have to, this is excitation table, now we have to write the circuit excitation table, this is circuit excitation table, and this is be done by using state diagram. So, again here I can draw the state diagram 0 0 0 1 0 0 0 0 1 1 0 and 1 1, this is up counter, okay, up counting is done, right. So, here this is nothing but this is Q1 and this is Q2, means we are having Q1 and Q2 like this 0 0 0 1 1 0 and 1 1. Is it clear all of you? So, write like this, I have written here Q and Q2 0 0 0 1 0 0 0 1 1 0 and 1 1. Okay. So, now we will check the next state. So, 0 0 is present state, next state is 0 1. So, here it will be 0 1, okay. This one. Then what is the next state for 0 1? Next state is 1 0. Then 1 0 next state is 1 1, and next state of 1 1 is 0 0. Is it clear to all of you? This is nothing but next states. This is the next states. These are the next states. Okay. So, now using this thing we will be writing the circuit excitation table. So, let us check the excitation table. 0 0 will be having J or K 0 cross, 0 1 1 cross, 1 0 cross 1 and 1 1 cross 0. So, here like that for 2 flip flops we need 2 bit counter 2 flip flop. So, this is the flip flop number 1 and this is flip flop number 2, flip flop 1 and flip flop 2. So, 2 inputs J1 K1 and J2 K2. So, J1 K1 will be depending upon Q1 and Q1 star, okay, and J2 K2 will be depending on Q2 and Q2 star. So, let us draw Q1 and Q1 star. So, 0 0 for 0 0 what will the value of JK? 0 cross. So, here we will write as 0 cross. For 0 1, for 0 1 what is the value? For 0 1 JK is 1 cross. So, it will be 1 cross. Then for 1 1, for 1 1 is cross 0. So, we will be writing as cross 0, and next is 1 0, for 1 0 we are having cross 1. So, we will be writing as cross 1. So, now for values of J1 and K1 is done from the excitation table, got it. Now, for second flip flop J2 K2, for J2 K2 what we will do? Just check one thing, we will be erasing these things, it will be easy for you to understand. So, it will be 0 1 1 0 1 1 and 0 0. Okay. Now, for J2 K2 we will be giving attention for Q2 and Q2 star. Okay. So, for 0 1 let us check, for 0 1 we will be having 1 cross, 0 1 will be having 1 cross. So, we will be having J2 K2 as 1 and cross, got it. Then for 1 and 0, for 1 0 we are having, for 1 0 we are having cross 1, we are having cross 1. So, it is cross 1 like that 0 and 1, for 0 and 1 what will be the value of JK? For 0 and 1 will be having 1 cross. So, it will be 1 and cross. Then for 1 and 0. For 1 and 0, let us check, for 1 and 0 it will be cross 1. So, it will be cross 1. So, we will be having 1 cross cross 1, 1 cross and cross 1. So, the inputs are clear, J1 K1 and J2 K2 for 2 flip flops, we have got the values. Now, we will be writing the K map. There will be 4 K maps, one is for J1, one is for K1, one is for J2 and one is for K2. Okay. So, like this is for J1, this is for K1, this is for J2, this is for K2. The inputs are Q1 and Q2, these are the two inputs. Not, do not consider Q1 star and Q2 star, because they are the next states, right. We will be only consider Q1 and Q2. So, let us check, this is Q1 and Q2, like that you write in every places Q1 Q2, Q1 Q2, Q1 and Q2. Okay. So, now let us check that thing. For J1 we are having 0 1 cross cross, 0 1 cross cross. So, write that 0 1 cross cross. Okay. For K1 we will be having cross cross 0 1, cross cross 0 1, 0 1. For J2 we are having 1 cross 1 cross, 1 cross 1 cross, cross 1 cross, and for K2 we are having K2 and cross 1 cross 1, cross 1 cross 1. The K map is done. Now, we have to group the ones and cross. So, here only one group is made for J1, here also one group is made, for here all 4 will be one group, okay. And here also all 4 will be one group. Okay. So, from this we will be having the value of J1 is equal to, J1 will be equal to Q2. Okay. The K map value for this grouping is J1 is equal to Q2. For this K1 will be again Q2. This is all 4 grouping in a single group, all 1 1 cross cross, total 4 in a single. So, it is a quad. So, J2 will be 1, J2 will be 1 and K2 also will be 1. So, we are having 4 equation, J1 is equal to K2, K1 is equal to Q2, sorry, J1 is equal to Q2, K1 is equal to Q2, J2 is equal to 1 and K2 is equal to 1. So, now we are going to draw the final diagram. Okay. So, we are having 2 bit synchronous up counter, 2 bit synchronous up counter. So, we are having JK flip flop using JK flip flop. So, 2 JK flip flop is there, JK flip flop 1 and JK flip flop 2. This will be J1 K1, J1 K1, this will be Q1 and Q1 bar, this is J2 K2 and this is Q2 and Q2 bar. We are just now drawing the format. Okay. Now, we are having 2 inputs J1 K1, J2 K2, K1 K2, K1 Q2 Q2 bar. Okay. Now, we are going back to the equations whatever we have got, J1 is equal to Q2, K1 is equal to Q2 and J2 is equal to, J2 is equal to 1 and K2 is equal to 1. Okay. So, this is Q2, right. Q2 is given input to J1 as well as for K1. Okay. Same is given. So, this Q2 will be given as input to J1 as well as K1. Is it clear to all of you? Q2 is given as input to J1 and K1. Okay. Now, J2 and K2 is 1, J2 and K2 is 1. So, J2 and K2 is going to logic 1. J2 and K2 is going to logic 1. Okay. So, this is nothing but Q1, this is Qn bar, okay, and like that we have done, and this is synchronous. So, same clock pulse is given the same time to both the flip flops. So, same clock pulse is given to both the flip flops. So, this is the final diagram is for 2-bit synchronous up counter. Okay. Let us take another example, design of 3-bit synchronous up counter using T flip flop. Here it is mentioned that T flip flop. So, you have to take T flip flop itself, okay. And this is 3-bit, 3 bits means 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0 and 1 1. So, total 3 bits means 3 flip flops and number of states is 2 to the power 3 means 8 states. Maximum count 8 minus 1 7. Okay. From question itself we have done these things. So, now we can draw like this 0 up counter. So, the combination will be 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. So, up counting like this, this is nothing but the state diagram, okay, up counter. So, let us check the states. First of all, we have to decide the number of T flip flop. So, 3 bits. So, 3 T flip flop is needed. Now, we have to draw the excitation table of T flip flop. So, let us do that. So, excitation table of T flip flop 0 0 0 1 1 0 and 1 1. If you have any doubt regarding the T excitation table, please refer the lecture video of T flip flop. So, we will be having T as 0 1 1 0. Okay. 0 1 1 0. So, now with this excitation table, we will be writing the circuit excitation table. So, I will be just writing the table once again. It will be useful for you to understand 0 0 0 1 1 0 1 1. So, 0 1 1 0, this is the excitation table. Okay. So, using this we will be like that. Now, 3 flip flops, flip flop C, flip flop, and T is having only one input. So, flip flop C, B and A. Okay. So, these are the present states. Again circuit diagram will be, state diagram will be like this 0 1 1, 1 0 0, 1 0 1, 1 1 0 and 1 1. Okay. I am writing both the things, so you can easily understood by you. So, up counting like this. So, what will be the sequence? If 0 0 0 is present state, the next state will be 0 0 1. Okay. So, it will be as 0 0 1, like that we will be writing 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1, and the next state for 1 1 is 0 0 0, next state for 1 1 is 0 0 0. Is it clear to all of you? These 3 are the next states, these 3 are the next states. Okay. So, now for TC, we will be checking as QC and QC plus, this one QC and QC plus. So, let us check this circuit, this excitation table and draw this circuit excitation table. Okay. So, 0 0 will be having T as 0, 0 0 will be having T as 0. Then for 0 0, for 0 0 again 0, for 0 0 again 0. Okay. Now, 0 1, for 0 1 will be having T as 1, for 1 1 will be having 0, 1 1 will be having 0, when 1 1 will be having 0, then 1 1 will be having 0 and 1 0 will be having 1. So, the final is 0001 and 0001, like that TB also will be like this 01 01 01 01. You can check like this. What will you check? For TB you will be have to checking QB and QB plus, okay, and from this circuit excitation table you can make the circuit excitation table. Then for TA all will be 1, all will be 1. You can check it. For TA you have to check QA and QA plus. So, see QA 0, QN plus 1. So, for 0 1 1, for 1 and 0 will be 1, like that you have to make the TC, TB and TA. Okay. So, this circuit excitation table is clear to all of you. Now, we have to make the K map for this. So, we are having 3 K maps, one is for TC, one is for TB and one is for TA. Okay. So, like that this is for TC, this is for TB and this is for TA. We have just written the values whatever we have got in the previous slide, whatever we have got the previous slides. The inputs are QC, QB and QA. So, we will be write that QC, QB and QA, QC, QB and QA, here also QC, QB and QA. Okay. So, now will be the grouping will be done, only one group, here also this all 4 and here all, total all 8 ones will be grouping. So, for this TC value will be QB QA, QB QA, TB value will be QA and TA will be 1. This is nothing but the grouping of K map. I am not going to detail in this. If you have any doubt of K map, you can refer the previous video lectures of K map. It is discussed over there. So, these 3 equation will be getting TC, TB and TA. So, now my question was 3-bit synchronous up counter using T flip flop. So, 3-bit means 3 flip flop, T flip flop 1, we have taken C, B, A. So, we are putting as A, T flip flop B and T flip flop C. So, 1 1 input in every case, T A, T B and T C. Synchronous. So, same clock pulse is getting given to all the flip flops at the same time simultaneously. Now, we are having the equations. The equations are TC is equal to QB QA, TC is equal to QB and QA, TB is equal to QA, TB is equal to QA and TA is equal to 1. So, first of all TA is equal to 1. So, we are giving TA as logic 1, this is done. TB is equal to QA. So, this is TA, so this is QA. So, TB is directly connected to QA. Okay. Now, third one is TC is equal to QB and QA. So, this is QB, this is QB and this is TA. So, this is QB and this is QA, then it will be a AND operation and it will be given that TC. So, this is nothing but QB QA. Okay. Clear? So, this is nothing but QC and this is QC bar, this is QA bar, this is QB bar and this is QC bar. Okay. So, this is the final counter design for 3-bit synchronous up counter. So, in this lecture we have discussed the basics of counter, classification of counter and we have designed 2 counters, one is 2-bit synchronous up counter and second one is 3-bit synchronous up counter. Thank you.